Welcome to Gnana Deeksha, concept-based digital learning. Myself, Nemmani Madhusudhan, TGT Mathematics, working in Telangana Social Welfare Residential School, Shaikpet, Hyderabad, HRR West. Today, I am dealing with 10th class coordinate geometry introduction as well as section formula and its applications. So, let us see today's learning outcomes. At the end of this class, you will be able to explain what is coordinate geometry, what is a Cartesian plane, what are coordinates, axes, and what are quadrants, and also able to give real life applications of coordinate geometry, and able to define and derive section formula and its application, which is midpoint formula. Now come to introduction part. So what is mean by coordinate geometry? The use of algebra to study geometric properties, that is operates on symbols, is defined as coordinate system. Come to exact definition of coordinate geometry. A system of geometry where the position of points on the plane is described using an ordered pair of numbers. The method of describing the location of point in this way was proposed by the French mathematician René Descartes. He proposed further that curves and lines could be described by equations using the technique, thus being the first to link algebra and geometry. In honor of his work, the coordinates of a point often referred to as the Cartesian coordinates and the coordinate plane as the Cartesian coordinate plane. Now, to locate the position of a point on a plane, we require a pair of coordinate axes. So, he took horizontal number line, which is called x-axis, and another vertical number line, which is known as y-axis. The point of intersection of these two axes is known as origin. These two number lines act as reference lines to locate any point on the plane. So this plane is known as Cartesian plane or XY plane. Now the distance of a point from y-axis is called its x-coordinate or abscissa, and the distance from a point from x-axis is called its y-coordinate or ordinate. Every point on the Cartesian plane represents an ordered pair x, y. The coordinates of a point on the x-axis are of the form x, 0, and of a point on the y-axis are of the form 0, y. Now coming to coordinates of a point which is the intersection of x-axis and y-axis, origin. The coordinates of origin are 0, 0. A part of x-axis, right side of origin, OX, is called positive x-axis, and left side of origin, OX' is called as negative x-axis. And a part of y-axis above the origin, OY, which is called as positive y-axis, and below the origin, OY' is known as negative y-axis. These x-axis and y-axis divide the total plane into 4 parts. They are known as quadrants. Now, quadrant 1. What is the quadrant 1? This quadrant 1 is bounded by positive x-axis and positive y-axis. So, every point in the quadrant 1 represents an ordered pair having the sign plus, plus. And these axes, x-axis and y-axis, does not belong to the quadrant. Now coming to quadrant 2. Quadrant 2, which is bounded by negative x-axis and positive y-axis. So every point in the quadrant 2 having the sign minus, plus, and as usual these axes does not belong to the quadrant. Coming to quadrant 3. This quadrant 3 is bounded by negative x-axis and negative y-axis. So every point in the quadrant 3 represents an ordered pair having the sign minus comma minus. These axis also does not belong to the quadrant. Finally, quadrant 4, which is bounded by the positive x-axis and negative y-axis. So every point in the quadrant 4 represents an ordered pair having the sign plus comma minus, and these axes also does not belong to the quadrant. Now let me ask one question. The point 3 comma 0 lies in which quadrant? Quadrant 1 or quadrant 4? What is your answer? The answer is none, because the point x comma 0 lies on x-axis. Why? Here y coordinate is 0. Y coordinate means distance from x-axis. Right? So distance from x-axis 0 means the point x comma 0 lies on x-axis. Similarly, the point 0 comma y lies on y-axis. So what is our answer? The point 3 comma 0 does not belong to any quadrant. It lies on x-axis. Now what is the use of this coordinate geometry in our regular life? Let me explain some real life applications of coordinate geometry. So I have chosen some examples where we are using coordinate geometry frequently. The first one, while scanning a photocopy and air traffic management and regulation, and in geography, and live tracking of a delivery boy, and the fourth one, storage of photos in digital cameras, and seating arrangement in the theaters, and for storage purpose we are using text file or PDF, and finally in games and sports also we are using the coordinate geometry. Let me explain briefly one by one. Now, how we are using coordinate geometry in scanning a photocopy. I hope everyone have seen a scanner. The scanner will copy or store any photocopy digitally using coordinate geometry. For example, a document is here going to be scanned. The scanner will distribute the image into different points. These points are coordinated with the help of two axes. The distance from these axes will store digitally, and the color of the particular point is also stored digitally. After processing all this, we will get our hard copy. Next, coming to the second example, air traffic management and regulation. Location of air transport. We all have seen the aeroplanes flying in the sky, but might have not thought of how they actually reach the correct destination, and actually all this air traffic is managed and regulated by using coordinate geometry. Coordinate geometry is a tool which will answer our following questions. What is the current location of an aircraft? How much time is required from one place to another place traveling at a certain speed? So these questions answers will be given by coordinate geometry. All the air traffic is controlled by air traffic controller. A controller must know the location of every aircraft at any particular instant of time in the sky. Coordinates of any particular vehicle are used to describe its current location of the aircraft. Now imagine, if coordinate system does not exist, the pilots, aircraft controllers, passengers in the flight and the persons are waiting for the flight will not be able to get the location or position of aircraft. So, coordinate system is one of the most important part of air transport. Coming to third one, geography. How coordinate geometry used in geography. So, we use coordinate geometry in the geography. On the globe, we have horizontal lines across the globe are known as latitudes, and the vertical lines across the globe are known as longitudes. To find the position of any place on the globe, we can locate by taking latitudes and longitudes as reference lines like x-axis and y-axis. Now coming to how live tracking of a delivery boy movement means, I think you people have ordered some food items through Zomato and Swiggy. Then how you will track the delivery boy movement through your phone. So the live tracking of delivery boy is shown by Zomato or Swiggy or other applications on your mobile. These applications use Google Map for this purpose. Google Map is an example for a 2D plane or a Cartesian plane. Every location on the map is assigned by specific coordinates. When you order food on these applications, then your delivery location and delivery by location are captured in terms of coordinates by Google Map. So when the delivery boy moves, the satellite of Google captures new position after each fraction of time in terms of coordinates, and the movement of delivery boy is shown on your mobile. Coming to how we are using coordinate geometry in digital cameras. Nowadays we are using digital camera in everywhere to take photos, and later we are taking the printouts. Here also the concept of coordinate geometry involved. For example, we have taken a photo with digital camera. See this, the two lines, the two edges are treated as x-axis and y-axis. Now complete image is divided into number of points. Now we will get every point in the form of coordinates, and it will store digitally, and the colors, font, everything is stored digitally. So now we can take a photograph. Now finding seat in theaters. I think you people went to a movie. Then how you can find your seat in the theater? See that here also we are using coordinate geometry. Basically the seating arrangement in theaters will use coordinate system. Each column starts with the name A, B, C, D and so on. And in each row we have seats numbered from 1, 2, 3, 4 and so on. These columns act as y-axis and row will act as y-axis. So every seat represents a coordinate which represents row and column. So we can easily find out our seat in the theater. Now, so we are using text file or PDF to store the content. The text file or PDF file which we open is also an example of coordinate plane. In this, the words or images written or modified with the use of coordinate geometry. Any PDF file which consists text or image and different shapes are placed there according to 2D coordinate system, that is Cartesian plane. Now finally, so we are using in sports and games also coordinate geometry. In sports and games we use coordinate geometry. For example, the football court, so which is example for Cartesian plane. The position of ball and movement of the ball, every part of time is represented by coordinates. So in this way we are using the coordinate geometry more frequently in our daily life. Coming to the next topic, that is section formula. Okay, what is meant by section formula? For example, consider 2 points A x1 y1 and B having the coordinate x2 y2. And we have a point P x comma y which divides AB internally in the ratio m1 is to m2. We need to find the coordinates of the point. What is the point dividing here? P x comma y, which is dividing AB in the ratio m1 is to m2. Okay, then we need to find the coordinates of point P x comma y. Now, so we have taken, to find the coordinates of point P, we have taken A x comma x1 comma y1, B x2 comma y2. Then first one, what we need to see, draw perpendicular AR, PS and BD onto the x-axis. From point A, from point P, from point B, we should draw perpendiculars onto the x-axis, and from the same point we should draw perpendiculars onto the y-axis. Those are AF, PE and BD. Right? Now draw AQ, PC, which are parallel to x-axis. So we know that, we discussed earlier, the distance from x-axis is known as y-coordinate, The distance from y-axis is known as x-coordinate. Now observe the diagram. We need to take some values. Those are, see the diagram, AR, which is the distance from x-axis. AR, which is equal to QS, is nothing but y1. Now CT is equal to PS is equal to y, distance from x-axis. Now what is the distance of point B from y-axis? BT, which is equal to y2. Now similarly, distance from y-axis for the point A, that is FA, is equal to x1. For the point B, what is the distance from x-axis? That is DB is equal to EC, which is equal to x2. And what about the distance of point P from x-axis? EP is equal to FQ is equal to x. Okay, and also now we need to get PQ length. See the diagram, PQ length. How we can get PQ? That is PS minus QS. Already we got PS and QS values. What are the PS values and QS values? Y, Y1. So the value of PQ will be Y minus Y1. Now BC value. See the diagram, how we will get BC? It will be BT minus CT. We know the values of BT and CT. Those are Y2 and Y. So what is the value of BC finally? Y2 minus Y. Similarly, get the value of AQ. AQ can be written as FQ minus FA, which is FQ value x, FA value x1. Finally, x minus x1. And what about the value of PC? PC can be written as EC minus EP. EC value x2 and EP value x. So finally, PC value x2 minus x. Now, see the diagram. I need to consider here two triangles. They are triangle PAQ and triangle BPC. If you observe carefully these two triangles, we know that angle AQP is equal to angle PCB. Why? They are maintaining 90 degrees. Now another angle, angle PAQ is equal to angle BPC. Observe carefully, they are corresponding angles. So in these two triangles, we got two angles are equal. By AA similarity, we have similarity of triangles. By AA similarity, triangle PAQ, which is similar to triangle BPC. If two triangles are similar, then corresponding sides are in proportion, or the ratio of corresponding sides is equal. What are the corresponding sides in both the triangles? PA by BP, which is equal to AQ by PC, which is equal to PQ by BC. Now, see here, we got the ratio PA by BP is equal to AQ by PC is equal to PQ by PC. Now, we need to replace the values of PA, BP, everything. What is the value of PA and BP? We know that it is dividing in the ratio M1 is to M2. So, PA by PB, which is nothing but M1 by M2. What is the value AQ we got? Which is X minus X1. What is the value of PC? X2 minus X. What is the value of PQ? Y minus Y1. Finally, what is the value of BC? Y2 minus Y. If you replace all the values, we are getting M1 by M2, which is equal to X minus X1 by X2 minus X, which is equal to Y minus Y1 by Y2 minus Y. Now, we need to find the X coordinate in the point P, that is X. How? By equating M1 by M2 is equal to X minus X1 by X2 minus X. If you do cross multiplication, what happens? M1 into X2 minus X, which is equal to M2 into X minus X1. After multiplying M1x2 minus M1x, which is equal to M2x minus M2x1. Now we need to find X term here, X value. So take X terms one side and remaining terms one side. So that I am taking M2x1 from RHS to LHS. We will get M1x2 plus M2x1, which is equal to, I have taken common X. The remaining term will be M1 plus M2. So X is equal to M1 x2 plus m2 x1 by m1 plus m2. Okay, this is the x coordinate. Now what about y coordinate? So to get the y coordinate, we need to equate m1 by m2 is equal to y minus y1 by y2 minus y. Do cross multiplication. m1 into y2 minus y, which is equal to m2 into y minus y1. Then if you multiply m1 by 2 minus m1 by, which is equal to m2 by minus m2 by 1. Here also I need y term. So y terms take one side, remaining send one side. So I have taken minus m2 by 1 from RHS to LHS. So we got m1 by 2 plus m2 by 1, which is equal to y into m1 plus m2. Finally, y equal to what? m1 by 2 plus m2 by 1 by m1 plus m2. So we got x coordinate and y coordinate from the point P. Okay. Now we got section formula, that is m1x2 plus m2x1 by m1 plus m2, comma m1 by 2 plus m2 by 1 by m1 plus m2. Now we are going to see some applications of section formula where we are using. So using section formula only we can get midpoint formula. So what is known midpoint? If AB is a line segment which is divided by the point P x comma y in the ratio 1:1, means equal ratio, then the point P is known as midpoint of AB. Now to find the midpoint of AB, what are the changes we need to take? Here the ratio m1 and m2 will be 1:1. So put m1 equal to 1 and put m2 also 1 in the section formula. We'll get the midpoint formula as x1 plus x2 by 2, comma y1 plus y2 by 2. So this is a midpoint formula which is application of section formula. And also next concept, this is also application of section formula. Points of trisection. What is meant by trisection? Tri, 3, section, equal parts. So if we have a line segment AB, the points which divides AB into 3 equal parts, those points are known as points of trisection. For example, I have taken AB line segment, the point P and Q here dividing line segment AB into 3 equal parts, that is AP is equal to PQ is equal to QB. That's why here P and Q divides AB into 3 equal parts. That's why P comma Q are called points of trisection. Okay. So let us take some problems based on section formula. See the question on the board. Find the coordinates of a point which divide the line segment joining the point A 4, minus 3, point B 8, 5 in the ratio 3:1. So here I am taking the point P x, y, be the point which is dividing AB in the ratio 3:1. Here 3:1 means m1 is to m2 how much? 3:1. And the first point A 4, minus 3 we can take it as x1, y1. Second point B 8, 5 we can take it as x2, y2. So we got all the values to substitute in the section formula. What is the section formula? m1x2 plus m2x1 by m1 plus m2, comma m1 by 2 plus m2 by 1 by m1 plus m2. So put the value of m1 as 3 and 3 into x2 value how much? 8 plus m2 how much? 1, x1 how much? 4, 1 into 4 by 3 plus 1, m1 by 2, m1 will be 3 into y2 how much? 5, so 3 into 5 plus 1 into 3 by 1 plus 3. So if we simplify, the total value becomes 7. The x coordinate will be 7. If we simplify y coordinate, finally we got the answer is 3. So we got the coordinates of point P x, y which is equal to 7, 3. So let us go to second problem. Midpoint formula. So we got midpoint formula what? x1 plus x2 by 2, y1 plus y2 by 2. Here is one question on the midpoint formula. Find the midpoint of point P, coordinates are 1, minus 3 and point Q whose coordinates are 5, 7. So the points P 1, minus 3 we can take it as x1, y1, and the point Q 5, 7 we can take it as x2, y2. So take the midpoint formula x1 plus x2 by 2, y1 plus y2 by 2. So what is x1, what is x2 here? 1, 5. So 1 plus 5 by 2, what is y1, what is y2? Minus 3 plus 7 by 2. So 5 plus 1, 6 by 2, 7 minus 3, which is equal to 4 by 2. If you simplify, 3, 2. So finally the midpoint is 3, 2. Okay students, let's see the summary of today's session. So in this session, we discussed about coordinate geometry, its definition, and what is a Cartesian plane, and what are the coordinates of a point, what are axes, and the father of coordinate geometry, who's that? René Descartes. So we discussed about the history of René Descartes and how to locate a point on the Cartesian plane, how we can represent a point on the Cartesian plane, and what are the coordinates of origin, and what are axes, and this x-axis and y-axis divide the plane into quadrants, how many quadrants, and in each quadrant which type of points having the signs. So we discuss clearly. Next, we discuss the uses of coordinate geometry in our daily life. We are using coordinate geometry in our daily life frequently, more frequently we are using, right? We discuss where we are using scanning a photocopy, or in air traffic management or regulation, in geography also, and how we can live tracking a delivery boy movement, how we can store photos in digital camera, and in the theater how the seating arrangement takes place, and while storing it content we use text file or PDF. Here also we are using coordinate geometry. In games and sports also we use coordinate geometry. Okay, next we discuss about what is section formula, how to define and how to derive the point of division of a line segment. So we got section formula and we applied section formula to derive the midpoint formula, which is application of section formula, that is x1 plus x2 by 2, y1 plus y2 by 2. One more application of section formula, that is points of trisection. What is mean by trisection we discuss. Okay, then how to apply this section formula into our problems by taking the formulas. I hope everything is clear for you. Thank you.